The universe is 13.8 billion years old. Everyone agrees on that. It's written in every textbook, taught in every classroom, printed on the walls of every planetarium on Earth. So how did the James Webb Space Telescope find a galaxy that looks older than that? Not a typo. Not a rounding error. A galaxy that appears to have been quietly forming stars for nearly 2 billion years, sitting at a point in cosmic history when the universe itself was only 300 million years old. 2 ages. 1 timeline. They cannot both be true. And yet, here we are. Stick around, because by the end of this video, you're going to understand exactly why some of the smartest astrophysicists on the planet are using words like impossible, and why one scientist has proposed that maybe, just maybe, we've had the age of the entire universe wrong the whole time. Let's rewind. When James Webb launched at the end of 2021, it had one job that mattered more than any other: look back in time. Because that's what a telescope really is, a time machine. Light takes time to travel. The further away something is, the older the light is by the time it reaches us. Webb's giant gold mirror and its infrared eyes were built specifically to catch the faintest, most stretched out light in the universe, light from the very first galaxies that ever formed. Astronomers expected to find small, faint, simple smudges of light. Baby galaxies. Barely their specks representing the first fumbling attempts of the universe to make structure out of chaos. That is not what they found. Instead, Webb started sending back images of galaxies that were bright, massive, structured. Some of them contained almost as many stars as our entire Milky Way, except they existed at a point when the universe was less than 5% of its current age. One astrophysicist, staring at the data, put it about as plainly as a scientist ever does in public: it's bananas. Let's get specific, because the details here are what make this genuinely strange. An international team of astrophysicists went digging through a patch of sky near the Big Dipper, a region the old Hubble Space Telescope had already photographed back in the 1990s and considered, frankly, kind of boring. Webb looked at the same patch of sky. And buried in the data were 6 strange little dots of light. Too bright. Too sharp. Too structured to make sense. When the team calculated how far back in time these objects existed, the numbers didn't add up. These candidate galaxies appeared to exist somewhere between 500 and 700 million years after the Big Bang. That's incredibly early, a cosmic infant, in relative terms. But they weren't infants. They were giants. Each one packed with a number of stars rivaling the modern-day Milky Way, a galaxy that took over 13 billion years to build. Under the standard model of cosmology, that timeline doesn't work. There simply shouldn't have been enough time for gas and dust to collapse, ignite, form stars, and organize into a mature galactic structure that fast. It's like finding a fully grown oak tree in a forest that was planted yesterday. If 6 impossible galaxies wasn't enough to make cosmologists nervous, one particular discovery took things even further. In a study published in 2026, researchers led by astrophysicist Rohan Naidu measured something called the redshift of a distant galaxy, redshift being the tool astronomers use to figure out how far away, and therefore how far back in time, an object is. The higher the redshift number, the older the light, the earlier the galaxy existed. This galaxy came back with a spectroscopic redshift of 14.44. Translate that into cosmic time, and you're looking at a galaxy that existed when the universe was roughly 300 million years old. Here's the problem. When researchers examined what was actually inside that galaxy, its stars, its chemistry, its structure, the signature looked like it belonged to a stellar population that had already been quietly forming stars for nearly 2 billion years. Read that again. A 2 billion-year-old population of stars, inside a galaxy observed only 300 million years after time itself began. One of those numbers has to be wrong. Both cannot be true within the same cosmic timeline. And that is precisely the paradox tearing through astrophysics right now. Scientists have started calling it, informally, the impossible early galaxy problem. It isn't one weird photo. It's a pattern, showing up again and again, in galaxy after galaxy, all pointing to the same uncomfortable conclusion: something about our timeline of the early universe doesn't add up. At this point, you might be thinking the headline writes itself: the Big Bang is wrong. But real science is rarely that clean, and the actual explanations on the table are more interesting than a single dramatic headline could ever capture. There are three leading theories. Theory 1: the galaxies formed faster than we thought possible. Maybe the early universe was simply more efficient at turning gas into stars than our models assume. If star formation switched on harder and faster in the first few 100 million years, these galaxies could have grown up at a pace that looks impossible today but was actually just unusually fast. Some calculations suggest bright galaxies at these extreme distances may be over 100 times more common than pre-Webb models ever predicted. That alone would force a serious rewrite of how astronomers think galaxies are built. Theory 2: we're overestimating how big and old these galaxies really are. Measuring the mass and age of a galaxy billions of light-years away isn't like putting it on a scale. Astronomers infer it, comparing the brightness of the galaxy at different wavelengths to computer models of simulated starlight. Small errors in those models could make a galaxy look far older, or far more massive, than it truly is. It's possible some of this impossible data is really just the limits of our measuring tools showing through. Theory 3, the boldest one: our timeline for the universe itself is wrong. This is where things get genuinely radical. A physicist at the University of Ottawa named Rajendra Gupta has proposed a new cosmological model, one where the universe isn't 13.8 billion years old at all, but closer to 26.7 billion years old. Nearly double the age we've accepted for decades. Under Gupta's model, the further back in time you look, the bigger the gap grows between the old timeline and the new one. At certain extreme distances, his calculations suggest galaxies could be inferred to be over 12 times larger under the standard model than they actually should appear under his revised one. If correct, this single change would hand the early universe nearly twice as much time to build these massive, mature galaxies, instantly solving the paradox. It's a bold claim. It is not the consensus view. But it's a serious, published proposal, and it captures exactly why James Webb has become such a disruptive instrument. Scientists are comparing its impact to what the Hubble Space Telescope did to astronomy back in the 1990s, not just adding new pictures to the textbook, but forcing the textbook itself to be rewritten. It's easy to watch a video like this and file it away as cool space fact. But this isn't trivia. This is a live crack in one of the most fundamental frameworks in all of science, the timeline of everything. If early galaxies really did form faster than physics currently allows, we have to rewrite the rulebook on how stars and galaxies are built. If our measurements are systematically off, we need better tools and better models before we trust any of this data at face value. And if the age of the universe itself is wrong, if it's actually closer to 27 billion years than 14, that doesn't just change one number in a textbook. It ripples through everything: the age of the oldest stars, the timeline of the Big Bang, the entire scaffolding of modern cosmology. That's the real headline hiding underneath the clickbait one. Not a galaxy older than the universe, but a universe that might not be the age we thought it was. So no, James Webb hasn't literally found a galaxy that predates the Big Bang. Nothing in this universe breaks that rule. Not yet, anyway. But what it has found is arguably stranger: a growing pile of galaxies that simply shouldn't have had enough time to become what they are: bright, massive, mature, sitting at the very edge of cosmic dawn. 6 impossible galaxies near the Big Dipper. A galaxy with a stellar population 2 billion years old inside a universe only 300 million years old. And now, a serious scientific proposal that the universe itself might be twice as old as we've always believed. Whichever explanation turns out to be true, faster formation, flawed measurements, or a fundamentally older cosmos, one thing is certain. The universe just got a lot stranger than the textbooks let on. And James Webb is just getting started. If this blew your mind, hit subscribe, because every single week, this telescope is rewriting something we thought we already understood. See you in the next one.